Alright, so today we're doing solving square root equations, which is, like I said, similar to what we did on Friday, but it's going to be slightly different. Just a little bit more difficult problems. So first things first, it's going to be exactly the same as what we did. Is we have to get the square root isolated and then get rid of the square root. So like you can see on this first example right here, is that the square root is already isolated. So all I have to do to get rid of it is square both sides. So I'm going to square both sides. All right, I need to switch out my stylus. All right, so anyway, I square both sides. So on the left side, I get x squared. And on the right side, I just get what's inside the square root. So x plus 12. And like what we did yesterday is we got everything to one side. So you guys know I like to keep my a value positive. So I'm going to subtract x. This will work. And subtract 12 to both sides. So then I get x squared minus x minus 12 equals 0. And now I just need to factor the left side. So I'm going to use my ACB table, but this one's kind of easy. My stylus register. Come on. X minus 4, x plus 3. So hopefully you guys are getting good enough to where you can see those easier ones. If not, like I said, you just got to take some practice. So then I get x equals 4. Come on. You can do it, stylus. X equals negative 3. And then I have to check to make sure that both of those work. So I'm going to plug them back into the original. So I get 4 equals square root of 4 plus 12. So 4 equals square root of 16, which I know that works. And the next one, so I know this one is a solution. Next one is negative 3 equals the square root of negative 3 plus 12. Well, right from the get-go, I know that because this isn't a square root, the square root of nothing will give you a negative number, because a positive number, the square root of a positive number is a positive number, and we know the square root of a negative number is an imaginary number. So we know this won't work, but you can simplify it if you want. But that won't work, so that is extraneous. So just 4 is our solution. So now let's go over to the next one. So I got to isolate the square root, so I'm going to add x to both sides. Square root 4x plus 21 equals x plus 4, or 4 plus x, however you want to write it. And then, because the square root's isolated, I'm going to square both sides. On the left, I just get 4x plus 21. And on the right, that binomial squared, remember, means it's x plus 4 times x plus 4. So this is really where the big difference is between what we did yesterday, or Friday, I mean, and what we're doing today. Is you're going to have a possibility of having a binomial squared that you have to solve. That's the main difference. So 4x plus 21, I'm double distributing here, so I get x squared plus 4x plus 4x plus 16. I'm going to combine like terms. 4x plus 21 equals x squared plus 8x plus 16. As usual, if you can do this in less steps, be my guest. Move everything to one side. X squared plus 4x. I'm subtracting this stuff over. And I think that gives me minus 5. So I think this is going to be x plus 5 and x minus 1, which gives me x equals negative 5 and x equals 1. Make sure I check those. I really have room, so I'm going to clip here. So negative 5 and positive 1. Alright, so I'm just going to plug it into the simplified version. So the, oh crap, so, uh, 4x plus 21 square root equals x plus 4. Let's try the negative 5 first. So I get, this becomes negative 20 when I plug in negative 5 plus 21 equals negative 5 plus 4. Square root of 1 equals positive, it's negative 1. And that does not work because we're only looking for the positive values. Now I know you guys, some of you are probably thinking, oh well, square root of negative 1, square root of 1 has positive and negative. But remember, we're only focused on the positive ones. The only time we'll ever talk about negatives is if there's a little plus or minus in front. Now if you plug that into the normal equation, it'll be a little more obvious because you'll probably get 6 equals 4. Like if you plug it into this, but I plugged it into the simplified version, so just be careful with that. But we're gonna do some more examples. So, all right, and then check 1. So I got square root of, come on, square root. There we go. 4 times 1 is just 4, plus 21 equals 1 plus 4 is 5. So square root of 25 equals 5. That works. So I know if I go back down, I know that negative 5 did not work, but 1 did. So I had one extraneous solution there. Come on, let me click. All right, so I mean both these are pretty much the same thing. If we look at this one, the only difference is that it's already isolated, so we just start by squaring both sides. So I square the left, square the right, and I have to double distribute. And then on the left, this one over here is just one step away. So I'm gonna do this one on the left because the one on the right's pretty easy. So all I have to do is isolate the square root, and I need to subtract this 7 to do that. Come on, subtract the 7. Alright, so I have n minus 7 equals the square root of negative 3n plus 19. So then all I have to do is square both sides. So I get n minus 7 times n minus 7 equals everything that was inside. Double distribute here, so n squared minus 7n plus 49 equals negative 3n plus 19. Now, like I said, if you guys can do this quicker and you don't need to go through all these steps, I'm fine with that. So here I get n squared minus 14n plus 49 equals the same over here. I'm going to add 3n, subtract 19. So n squared minus 11n, it looks like, plus 30 equals 0. And if I use my ACB table, I'm going to get n minus 6 and n minus 5. If you don't believe me, you can check it, but this is going to save you guys some time so you can just get started on your homework. And then I get n equals 6, n equals 5. Put this in the check. Let's go back up here. So I got 6 and 5. Plug 5 in, and then equals 7 plus negative 3 times 5 plus 19. Oh crap. Plus Alright, so this becomes 5 equals 7 plus the square root of 4. 5 equals 7 plus 2. 5 equals 9. I know some of you are probably thinking, or have thought up to this point, is how come this doesn't work right here? Because the square root of 4 is positive 2, but it's also negative 2. So if we had a negative 2 there, then we would get 5 equals 5. Because we'd get 5, we'd get 5 equals 7 plus a negative 2, which would give us 5 equals 5. But, like I said, we only care about positive values here. So that's why we're getting two solutions, is because there is two possible square roots, but this problem only specifies positive values. So when you get into upper level math like calculus and stuff like that, you start paying attention to those. But that's where we're coming from here, because like we talked about, we have domain restrictions where you can't have the negative square root. Right now, that's all we're dealing with, so that's why we have to identify it. But anyway, where were we? Okay, so that doesn't work. So that means that 5 doesn't work. If I come down here, 5 was extraneous. And let's do the last one. So let's talk about 6. So 6 equals 7 plus the square root of negative. Oh my gosh, guys, this is driving me crazy. Negative 3 times 6 plus 19. 6 equals 7 plus negative 3 and 18. So that is negative 18 plus 19 is 1. If I could write 1, let me write 1, please. Thank you. So 6 equals 7 plus 1 is 8. That does not work either. So let me move down. Let me move down, please. Select touch. Alright, well, it's not letting me move, so we'll go that we have. So this doesn't work. So they are both. What in the heck is going on here? Both extraneous. So that means we have no solution. I know I'm writing over the top here, but I can't get the thing to move. No solution. Alright, so sorry, I know there was like a lag there, but it let me move the screen. Anyway, so there's only 8 problems in the homework, so why don't you guys do 5? So choose 5 of 8, and then just make sure you get those done. And let's see, you guys should have enough time to finish them. So I will have the sub collect them at the end of the period, and I will check those. So I will talk to you guys tomorrow. Hopefully, you have a good day.